So we're in the process of starting chapter 5.2, which is integration by substitution. What we're setting about to do here is to reverse the chain rule. Recall that the chain rule said that if we took the derivative of u to the power n, that would be equal to the derivative of u to the power n, the prime of that, times the derivative of u. If we reverse the chain rule, and we took the derivative of u to the power n u prime, the integral of u to the power n u prime with respect to u, this would be equal to u n plus 1 over n plus 1 plus the constant term. In other words, if the product that's attached to this integral is u prime, then all we have to do is add 1 to the power and then divide by that power. Couple of other rules. If we've got e to the power u prime du, then this is simply e to the power u plus the constant. And if we've got 1 over u prime du, then this is ln u plus the constant. So I'm going to give you an example of each of these rules. 1. If I'm asked to integrate 3x plus 4 to the power 10 times 3 dx, here we can consider u to be 3x plus 4. So du dx is 3, which is, u prime right there. So what's happening here is this is already in the form u to the power n u prime du. So based on our rule, then this integral is already, since 3 is the derivative of 3x plus 4, then we already have u prime situated where we want it to be. So we use the rule directly, and this is equal to 3x plus 4, add 1 to the power, divided by 10 plus 1 plus c. So this is 3x plus 4 to the power 11 over 11 plus c. Plus the constant. Don't forget the constant. An example of the rule involving, hang on 1 second here. Let me freeze this. All right, that's not going to work, so I'm going to have to go ahead and try to do B and C right here. An example for B is integral of e to the power x cubed 2x, sorry, x squared 2x dx, and this would simply be equal to ex to the power 2 plus c, because this part is already e to the power u, and 2x is already u prime. Finally, part C, 1 over 1 plus x cubed 3x squared dx. So observe that this bottom part is 1 over u, and this part here is u prime, right? The derivative of x cubed is 3x squared. So again, we apply the third rule, and this is the logarithm of 1 plus x cubed plus c. And it's really convenient if that product is already the derivative. If it's not, we have to work on steps to making it into that product. I'm sorry, I forgot the absolute value here. Absolute value. This is not a parenthesis, it's an absolute value. 1 plus x cubed. Okay, based on this rule right here, has to be in absolute value. So for some of these problems, all we need to do is check to see if the derivative is already there. I'm going to do some further examples in a second, but let me look at some of the first examples here and see what's happening. We may or may not need to manufacture something. So here, notice that u is equal to 9x plus 9. So u prime is equal to 9. And we already have that 9 in place here. So all we would need to do is add 1 to the power and divide by that power. All you need to do is establish that the power, that the u value is the same. Here u is x squared minus 18. So u prime is equal to 2x. Conveniently, that 2x is there already, so this is equal to x squared minus 18 to the 15 power over 15 plus c. So here, determine an appropriate substitution to simplify the integral. What they're asking us here for is that the substitution will be, for u, is equal to x squared minus 18, which is this choice right here, x squared minus 18. They're just asking you what would be necessary for the substitution. Here u is equal to x squared plus 1, so u prime is equal to 2x. Conveniently, there 2x is here already, so we immediately apply the rule to this. This is x squared plus 1 to the 7th power over 7 plus constant. So u in this case is 6x. That's the portion e to the power u. And u is 6x, so u prime is equal to 6, which is already here. So this is simply equal to e to the power 6x based on the second rule that I outlined earlier to you. The second rule says that e to the power u, integral of e to the power u times u prime du is simply equal to eu plus c. In this case, we have 1 over u is 1. So the u value here is 4 plus 5x squared. So u prime is equal to 10x. Notice that the 10x is already here. So again, we use the rule number 3. This is the logarithm of 4 plus 5x squared absolute plus c. Natural log, sorry. Now, if in this case we're not given a product here, so we would need to say let u equal to 2x plus 1. Let u equal to 2x plus 1. So u prime is equal to 2. And now we need to go into this and manufacture. Okay, we need to manufacture this. So this is going to become the integral of 2x. Let me write it on this side. This is going to become the integral of 2x plus 1 to the power negative 5. And we have to take this 2 and put it as 2 over 2 dx. Then what we would need to do here is bring bring the denominator 2 outside. So this is half 2x minus 1 to the power negative 5 times 2 dx. And now we have exactly what we need, where this is u and this is u prime with a half outside. So our integral now, if we take the integral, that half stays in the front. This becomes 2x plus 1 to the power, and if we add 1 to the power, it becomes negative 4 over negative 4 plus c. which is equal to negative 1 over 8, 2x plus 1 to the power negative 4 plus c. So you have to manufacture that value for u prime if it's not there. Here's another example. So let u equal to, I'm going to start on further to the left here. Let u equal to 1 plus r cubed. So u prime is equal to 3r squared. So now we look at our integral. We've got r squared 1 plus r cubed squared dr. So we would want to go ahead and put in the 1 over 3 and make this 3r squared 1 plus r cubed squared dr. And now we have exactly what we need here as being the derivative of 3r squared. Notice that this would have been 3 over 3, so I put the 1 over 3 outside. If I distribute it, it becomes 1 again, and we get back the original equation. So all we would need to do now is follow the rule for integration here, and this becomes 1 over 3, 1 plus r cubed 1 plus r cubed square to the power 3 this time, divided by 3, plus c, which is equal to 1 over 9, 1 plus r cubed plus c. Alright, so here we're going to let u equal to x to the power 6. So du, or u prime, is equal to 5x to the power 6. Notice that we have x to the power 5x to the power 5, sorry. Differentiated incorrectly. This is 6x to the power 5. So we already have x to the power 5. We need to manufacture for that 6. So our integral x to the power 5 e to the power x to the power 6 dx is now equal to 1 over 6, 6x to the 5th e x to the power 6 dx. So this is 1 over 6 and following the rule for integration. I'm having a little trouble with my pen here. Following the rule for integration, we would say 1 over 6 e to the power. This is what we need here. This is the u prime, and this is e to the power u. I can probably use another color to demonstrate that. Let's use another color here. This is u prime, and then this is e to the power u. So when we write the answer for this, we would say that this is 1 over 6 ex to the power 6 plus constant. Or you can simply write ex to the power 6 over 6 plus your constant. So u is equal to 8x plus 1. U prime is equal to 8. So integral of 1 over 8x plus 1 dx is equal to integral of 8 over 8 times 1 over 8x plus 1 dx. So we would bring that 1 over 8 outside. Integral 8 times 1 over 8x plus 1 dx. And now what we got here is this is u prime, and this is 1 over u. So the integral is equal to 1 over 8. I'll give myself some more space here. I'm probably going to have to go down at the bottom here. 1 over 8 ln natural log 8x plus 1 plus c. For question 10 here, u is equal to e to the power, sorry, the u part is 7 minus 6t, right? That's e to the power u. So u prime is equal to 6t, so negative 6. So our integral e to the power 7 minus 6t dt is equal to negative 6 over negative 6 times e to the power 7 minus 6t dt. So bring that negative 1 over 6 outside. We're left with negative 6 e to the power 7 minus 6t dt. So now we can see that this part is u prime, and this part is e to the power u du. And we follow the rule here, so the integral here would be negative 1 over 6 e to the power 7 minus 6t plus the constant. Okay, for this question, they're first asking us to use the substitution method to integrate, to evaluate the integral. So notice that this is u prime and this is u. So the integral is simply 9x plus 6 squared over 2. The other method is to distribute. So this becomes 81x squared plus 54. Oh, I forgot the c here, right? It's plus c. Plus 54 and then if we integrated this, sorry, this is 9x, not 9x squared. If we integrated here, this would be equal to 81x squared over 2 plus 54x plus c. And you can go through the process of combining this into a single fraction here. Combining that in a single fraction to see that the two answers are indeed equivalent. If you look at the answer that we have for the first one, 9x plus 6 squared over 2. And if we did FOIL on this, we would have 81x squared plus 108x plus 36 over 2 plus c. And if we divide it by 2, that would become 81 over 2x squared plus 54x. And then we would combine 36 plus c into a single constant. And that would show you that the two answers are pretty much the same thing, which is why they're equivalent. Okay, so question 12, I'm going to, in 13, I'm going to have to do them, because they require a bit of work. I'm going to have to do them at the bottom of the page. The weekly marginal cost, this is question 12, of producing X pairs of tennis shoes is given by the following function, where C of X is the cost in dollars. C prime X is 14 plus 200 over X plus 1. If the fixed cost is $3,000 per week, find the cost function. What is the average cost per pair of shoes if 1,000 shoes are produced each week? So for question 12, we're given first that C prime X is equal to 14 plus 200 over X plus 1. So C of X is the integral of 14 plus 200 over X plus 1 dx. So integrating here, we have this is the integral of 14 dx plus 200 over 1 over X plus 1 dx. So this is 14x plus, let's call this constant 1. Since we're already using C for the cost, let's use a K here, K1 plus 200 ln absolute value of X plus 1 plus constant 2. And at this point, we can simply combine the two constants. So we can say that C of x is equal to 14x plus 200 ln x plus 1 absolute plus a single constant. Okay, k1 plus k2 is equal to k. Now, given that the fixed costs, which is k, is equal to 3,000, as given, we can rewrite our cost equation as C of x is equal to 14x plus 200 ln x plus 1 plus 3,000. Now, the first one, the average cost per pair of shoes and that's for 1,000 shoes. Let's go back and look at it. By the way, this is the first answer. Yeah, that's the first answer, the cost function. And then we're dealing with average cost of a pair of shoes of 1,000 if 1,000 are produced. Cx cost x is equal to x C bar x, and these are formulas I gave you before, right? So C bar x average cost is equal to Cx over x. So your average cost is cost over x. So we're going to substitute our 14x plus 200 ln x plus 1 absolute plus 3,000 divided by x, which is 14. We divide each term by x. 14 plus 200 ln x plus 1 over x plus 3,000 over x. So this is C bar, by the way, C bar x average cost. So C bar for 1,000 shoes, we would substitute 1,000 in here and use a calculator. Okay, logarithm of x is 1,000, so 1,001. The absolute value is positive, so 1,001 is not negative, plus 3,000 divided by 1,000, which is 3. So this actually simplifies to 17 plus 200 logarithm 1001. Then I went to my calculator. Oh, I forgot the 1,000 on the denominator. My bad. 1,000 on denominator. So this is 14, sorry, it's 17 plus 200 ln 1001 divided by 1000. So I'm going to my calculator. This is 200 ln 1001 divided by 1000. So this is 17 plus 1.38, which gives me 18.38. As the average cost for producing a pair of shoes if 1,000 are produced. And then question 13, our last question. A yeast culture is growing at a rate of W prime T is equal to 0.8 e to the power 01 T grams per hour. That's the rate of change. If the starting culture weighs 8 grams, what will be the weight of the culture WT after T hours and then after 6 hours? So after T hours and after 6 hours. So let's set up our little problem here. We're given a rate of change of weight with respect to time is 0.8 e to the power 0.1 t. So in this case, u is equal to 0.1 t. So u prime is equal to 0.1. In order to manufacture that 0.1, Wt would be the integral. Well, let's take out that 0.8 right now to make things a little easier. 0.8 integral of e to the power 0.1 t dt. But now we need to input this u prime here because we have e to the power u here. So this is 0.8 integrals 0.1 over 0.1 e to the power 0.1 t dt. We're going to bring that 0.1 outside from the denominator, and we're left in here with 0.1 e to the power 0.1 t dt. So this is 0.1 divided by 0.8 divided by 0.1 is exactly 8. And here we've now manufactured, this is u prime and this is e to the power ud. So using the rule for integration, the integral here is e to the power 0.1 t plus the constant. Now going back to the problem, we're told that the starting culture weighs 8 grams. Okay, the starting culture weight 8 grams. So when the time is 0, okay, when Remember, we just calculated Wt here, W with respect to T. When T is equal to 0, Wt is equal to 8. So making that substitution, because we have to compute C. 8 is equal to 8 e to the power 0.1 times 0 plus C. So anything to the power 0 is 1, so 8 is equal to 8 plus C, so C is equal to 0. So Wt is equal to 8e 0.1t, since the constant term is equal to 0. And they're asking us to find the weight after 6 hours. So when T is equal to 6 hours, W6 is equal to 8 times e to the power 0.1 times 6. You put that into a calculator, and they want the answer rounded to hundredths. So this is equal to 14.58 grams.